Hello and welcome everyone to the second lesson of the course. For this second lesson, we are going to dig deeper into the Swift architecture and how the transmitting of messages happens practically. But first, let's refresh on some of the concepts we studied in the last lecture. We talked about Swift and we mentioned the what, the why, and the how. The what? Swift is the network that connects financial institutions together. Why? Financial institutions need to communicate together for multiple reasons, including payments processing, clearing and settlement, and fraud prevention. The how? Swift has certain standard formats, which is simply a standardized messaging system with a common language and format enabling financial institutions around the world to communicate with one another securely and efficiently. We also mentioned two standards. The first one was the MT format, or the ISO 15022, and the MX format, or the ISO 222. We started with the MT format and we went through its blocks, and we mentioned that there are 5 blocks present. We also mentioned that certain validation checks happen within the Swift net to make sure there are no errors in the messages that are being transmitted. Lastly, we discussed the concept of correspondence, where two banks have a RMA agreement, or a relationship management agreement, by setting up two accounts, one at each bank, where one is called the Nostro account and the other one is called the Vostro account. In this lecture, we are going to get a little bit more technical. By the end of this lecture, you should be able to answer the following questions. How are messages transferred from one bank to another? What component is needed to connect to the Swift network or the Swift net? How are messages validated in real life, and how does that reflect in the message? What is Swift naming convention for incoming and outgoing messages? And lastly, an application on a message example. Let's start by this simple diagram of a bank. Each bank has something called the SAA, or the Swift Alliance Access. This is the server responsible for routing the transactions between the financial institutions. It acts as the gateway through which financial institutions can connect to Swift in order to do two things: send and receive messages. Simply, each bank has an SAA which allows it to communicate with the other banks using the Swift network. But how can the Swift net identify the sender and the receiver? Yes, you are correct, using the BEC, which we discussed in the last lecture. Bonus information that nowadays most banks have started replacing the BEC with the IBAN to ensure its uniqueness. So if we imagine that this is the Swift network, and we have banks 1, bank 2, and bank 3. Each of these individual banks have its own SAA, and they connect to the Swift network, and in doing so, banks 1, 2, and 3 can communicate together through the Swift net. But the question now is, do banks always have to have their own SAA? Actually, the answer is no. Sometimes when a bank is too small and can't afford to purchase its own SAA due to the demanding hardware and software requirements cost, it goes to something called the Service Bureau. The Service Bureau is an institution that has its own SAA and connects to multiple banks, and in doing so can provide access to these banks to Swift network. An important thing to note here is that a service bureau need to have a Swift license and certification in order to operate. You can check the current service bureaus using the following link. Now we're going to talk about a very important process, which is the ACK or the acknowledgement process. Remember when we discussed the validation checks performed by Swift? Well, this is when it comes into place. In real life, when a bank sends a message through to the SAA responds back with the same message with either an ACK or an ACK flag. If the message is given an ACK flag, or sometimes we say if the message is ACKed, this means that the message is approved by Swift and subsequently it can proceed to be sent through the network. However, if a message is NACKed or not acknowledged by Swift, then the message contains errors and so it is rejected by Swift. The ACK or the NACK flag is basically the same message which is sent in this step with an extra block 1 basic header. We're going to discuss this in details in the next lectures. One of the things that people often confuse a lot about is the message direction. An important thing to note here is that the message direction is always given from Swift's or the SAA point of view. This means that if we have the bank here and here's the SAA, if there is an incoming message to the bank, this means that it's output from Swift, so it will be given the O character. If there is an outgoing message from the bank, which means that it's an input to Swift, so it will be given the I character. Now we're going to put what you learned into action. This is a sample from the MT103 message. Can you identify 3 things you learned in this message? Well, the first thing you should notice is those following characters. So this looks like the back, but it's a little different from the back. So is it the back or is it something else? Actually, this is called the LTA or the logical terminal address. The logical terminal address or the LTA is 12 characters. It's equal to the back code, which is 8 characters, plus an LTA letter, which is 1 character, plus the branch code, which is 3 digits. In the ISO 15022 message basic header, which is block 1, the LTA is always used, not the back. We will stop here for this lecture. In the next lecture, we will dissect every part of this message and relate it to the elements and concepts we've been discussing in the past lectures. Until then, I will see you in a bit.